Hello friends, welcome back to the bench. Today we have a Pyle, I don't know if that's how you pronounce it, Pyle PMX7BU mixer or audio board or whatever you call it. Basically 3 inputs and 1 output, and you can regulate the volume, and you can hook up 2 microphones and the headphones, and you can go through channel left and right. I got it for $9. Actually, kind of funny because first the user listed it for $9.99, and I bid on it, $10, and someone outbid me, and I didn't want it for more than $10 because I don't really need it. It's just for repair value, and I think the price went up to like $30 or something like that. But I guess the seller had the minimum price set, and it didn't reach the minimum, so it was relisted. I bid on it again, and this time I got it for $9.99. I'm happy with it. All right, let's take a look what we can do with it. Now, this is what it looks like. The first damage that we can see is the slightly bent rack. No big deal. I probably won't need it anyways. And I'm missing cup, whatever it's called, for the left and right channel, and a broken antenna. This is Bluetooth antenna because one of the inputs, this one, is Bluetooth, and these two are these two, channel 1 and 2, and master output. 2 microphones and headphones. Talk over and microphone level, balance between 1 and 2 microphone, and of course output volume. It's capable of reading from the USB the music, the buttons for next, previous, play, and mode, and also I assume these also work when you connect the phone. These probably also work. Okay, so what's wrong with it? I already tested it, so I know it indeed doesn't work because it was advertised as untested. How does it manifest? When we turn it on, these will go down and the red LED 1 lights up. I don't know if that's good or bad. But basically when you connect the output to the amplifier and input, I used an input from my computer. When you crank the volume up on the amplifier, then you hear slightly that the signal is making it through from the input to the output, but it's actually very difficult to even hear. So it's basically just leak. It's just the input signal is leaking. There's no amplification. So this is basically a power issue. Is for the same reason nothing happens when you turn on off do anything here, or volume, nothing gives any effect. So probably there are 2 devices in there. One is responsible for Bluetooth and all that, as a regular input. The other device is a regular audio amplifier. There's no equalizer or anything, so the circuitry inside should be relatively simple. However, it might also turns out to be a single FPGA inside, glued with epoxy resin, and we won't be able to do anything with it. So let's first get it open. and see what's inside. Okay, and here it is. What is this chip? 4558D. That's a dual OpAmp. And we have 1, 2, 3, 4, 5 of these. 6 of these. Why so many? Okay, do we see any signs of maybe something burnt, exploded? We definitely see that. That's too bad. So here's the problem. I thought the antenna would be plugged in on a pigtail, and I can just plug it out and plug the new antenna in. And this has been just soldered. This must cause like awful reception and awful communication. Let's check this soldering here. I've seen things like that. They did work. Why can you not see anything? Oh. Okay, you're not gonna see anything under the scope. Sorry. Crappy devices. No. Sorry about that, but trust me, it looks awful. Okay, let's get a little further to dig this board out. All right, the board is out. Now we get power through here. There's some lonely resistor over here. And as I suspected, the Bluetooth part is like a separate device that just has output connected to the amplifier, I guess. Okay, now what are we looking for? What is the pin 4 and 8? 4 and 8. Let's see voltages. I couldn't connect to the Bluetooth, so I don't know if it does work, but I assume it does work. It just needs to have an antenna fixed, and actually we can probably use the internal antenna fixed. Well, we'll see. Okay, let's catch a ground somewhere. Right. Okay, and on the last one, oh, hang on, this should be V minus, and this should be V plus, and we have 0.3 on V plus, 0.7. Oh no, 8 is this one. Sorry. Okay, 8, 9. This is the V plus. Okay, so we're getting 8 volts everywhere. Is that good? Should it be 8 volts? Let's see, what's the voltage typical? From 4 to 18 operating voltage. That's 7505, so that's 5 volt stabilizer, and that's probably just the supply for the Bluetooth part of it. I don't feel anything burning, but we're drawing only 43 milliamps, so I wouldn't expect any shorts here. Okay, both inputs behave the same way. No amplification, so it's not a problem of a single channel. Something past the probably initial amplification. Let's see this. Let's get a music, some radio. Let's connect the input. Okay, so there's discoloration, or is it just my imagination? Kind of looks like liquid damage. Slight discoloration over here. I can well believe that some gin and tonic was spilled on it. I guess it was being used by musicians, right? So this is our input, in non-inverting input. This is the inverting input. And let's check the output. What is on the output of this guy? Pin number 1. Okay, and on the output, let me confirm if I'm reading it right. Not 8 volts. Well, now it's saying 221 on the scope, but I wouldn't trust the scope when it comes to measuring voltage. This is beautiful input, inverting, non-inverting. Let's see the other one. So this is the other input, inverting, non-inverting, and output. But there's another, so one possibility is that all these amps need to be replaced. They're, faulty chip. But I would say it's kind of unlikely for all of them to break, unless this was some, I don't know, user error, high voltage. Although they go all the way to 18 volts, so operational voltage is up to 18 volts. So I wouldn't expect it to be the case. So one is the chip. Oh, and the output, because the other is the short on the output. If there is a short on the output, then output will be 0. 9 volts. 9 volts. Volume doesn't have an effect, to be expected. But yeah, so the chip itself could be shorted, the input and output. But is it possible that all of them, 1, 2, well, at least these two, because these are responsible for these two input channels. Okay, these chips are really cheap. They're like a few cents each. So I think I'm gonna order these chips, just preemptively replace them. Then I'll check these diodes over here, which actually I can do right now. I have a clue now. Found a lot of solder balls here. Some of them pretty big. All right, let's order the OpAmps and replace them and see if that will help. Alrighty, now the 3 short weeks later, we have our amplifiers. Meanwhile, I decided to check this one. The device for checking OAmps is like 10 bucks, maybe 15 bucks with shipping from China. But it's so simple. I know, you just need 3 resistors, maybe a cap. Just push the sine wave to the input and see sine wave on the output. I could not see the sine wave on the output, so I think it was actually responsible for this. So the easiest way is to just replace it. But I did one more thing, and this is kind of puzzling to me. So when I power it up, with 12 volts, well, 11.9, whatever, we're drawing 42 milliamps. And now when I check the voltages on V plus and V minus of this chip, all right, so this is where in this configuration that they're using it, because it's not, what is it called, symmetrical power. It's basically not powered by plus minus, it's powered by plus and ground. Right, so V minus usually sits on ground somewhere, and this one, I retraced the schematic more or less. It's a positive, what is it called, non-inverting amplifier, right, with negative feedback, and the negative goes to ground with 10K the 10K resistor and capacitor that I didn't write, but that's an electrolytic capacitor, probably 2.2 microfarads. So I was expecting to see very small, tiny voltage on the V minus, right? This is V plus, 9.7, 9.8, right? And V minus is 8.1. Oh no, this is 0.8. Oh, okay. This is 0.8. Okay. And this one was 9 volts. Okay, so that's good. For some reason I thought this was 8 volts, and now I see that it's 0.8. So my bad. Why did we lose focus again? Come on, camera, don't lose focus on me. All right, so this is good. So we got power supply or voltage, supply voltage on the chip, which means most likely the replacement of that amplifier will help. All right, it's still pretty much the same. That's not good. So what is going on here? Let me show you this, and let's get this out of the way for now. So I'm pushing a beautiful sine wave here, right? It goes through resistor and capacitor to move it above 0, right? Because we don't have symmetrical supply, right? So this is the plus. The negative is pretty much on the, hangs on the 0, and when you turn it off, it gets pretty much the same signal. So there's no amplification, right? So this is on, this is off. And the output, which is this guy, just gives me 4 volts on the output. That's exactly what I've been seeing before replacing the, oh, hang on, we got something on the output of the capacitor. What this, well, there is something. Let's see the actual output. Keeps turning off. Oh, there is output. Oh, it's a bit distorted over here, but that is the output, and that is the sine wave. It's only 215. Let's catch this guy, and oh, but I should have only one channel because I'm just pushing one channel, and I have that on both channels, so that's probably not good. This looks more like what do you call it, the interference and stuff. and there's no changes on the output. When I modify the volume, let's see, the volume all the way down, all the way up, and nothing changes. So this is still not working. I think we will be able to fix it. So this is my output, and if I control volume, not this one, no. Oh, now, oh, it just changes position roughly, negative 40 millivolts to +1 when it's highest, what do you call it, volume. Okay, so this is our output. It goes here through this resistor, I guess. And then it goes to this cap through the cap. Not for this cap, or yeah, it is a cap. Okay, it's time to take a break. So, what I do know is this. The input signal from the channel number 1 makes it to this amplifier, OpAmp. The output goes into the potentiometer. Potentiometer indeed changes the volume, so it does work, and it makes it here, and from there it makes it to here to the balance potentiometer, and I think this is one of the outputs that makes it here through the cap, and it goes to where are you? This guy. So this is second preamplifier, and from that preamplifier we go to the output. So I don't have a signal here, or at least it doesn't look like it. Okay, so our new suspect is this one, and some passive elements around it, but I would expect to have the input signal on it, unless it's broken in a way that it just lets current through inputs, because technically it shouldn't draw any current, or just draw some like microamps from the inputs, both of them. That's the rule number 1 of OpAmp. The current doesn't flow through inputs. It actually obviously does, but it's more like a leakage current. All right, let's take a little break and maybe replace this amplifier. Testing. Okay. Not bad. All right, so now after literally days trying to figure this out, I finally did. And it's absolutely embarrassing how simple the problem was. But before I tell you what exactly was wrong with it, I'm going to tell you what I thought was wrong. And this capacitor that I marked as, you know, something that could be replaced, it was showing kind of a abnormal ESR, abnormal capacitance, and it probably has some age to it. So I figured, yeah, let's replace this one. This 10 microfarad, no, not this one. This is 470 mic, 25 volts. That sits between the ground and every single op amp on this board. 1, 2, 3, 4, 5, 6. All of these between them and the ground is this capacitor. So obviously this should have been my first pick to just replace and see if the problem goes away. This was not the problem, although after replacing this capacitor, my output became a little bit better when it comes to the shape of the sine wave that I was inputting. So that definitely did help. Unfortunately, I replaced it with, because this one is 25 volts, I replaced it with 16 volt rated, so I'm going to have to replace that with the actual one, but I just wanted to test it. In this case, it's not going to be a huge deal, right? But I reproduced this entire circuit in the simulator, and I get the exact same results. So basically, my output is not amplified. Then what did I do in the simulator? Because I just started playing with it. What did I do? I just changed the single supply, the single rail supply, to a split rail supply. So +8, -8 volts instead of just positive 8 volts and just going to ground through that capacitor. And that fixed the problem in the simulator. Then I started thinking, what am I missing here? There's got to be something simple that I'm missing. And I'll show you the solution. So the positive and negative was 8. And oops, is this one? No, this one. Yeah. And now it's 24, right? Instead of 8. It's basically 12 volts multiplied by 2. And that's the difference that I'm getting, at least the DC voltage, between the positive and negative. So that must be the problem, right? Yes, it is. It sure is. As I said, I'm embarrassed to say what the problem was. The input, the voltage must be AC. That's why it seemed a little bit curious to me that why do we have 3 diodes over here, 3 3 rectifying diodes over here, plus big biffy the resistors, and 2 Zener diodes. That's why, because we're getting AC from here, so we can actually produce the split rail. And I should have known that before, because I asked a friend of mine and immediately when I told him my results, what is wrong, or what results I'm getting on the output of the op-amp, first question, or his first, eyebrow raising, was that why is this op-amp supplied from a single rail? Why isn't there a difference? It's, the input signal is going to be too close to the ground, and yeah, I didn't see the actual trimming of the signal, so I didn't think that was the problem. But yeah, that was the first thing, and I should have clanged on to that immediately. But instead, I started testing the cabs and going all kinds of directions. Second thing that he said, that definitely there's no point of inputting signal into the op-amp and having no amplification on the output, or at least current-wise, right? Or not counting like maybe a voltage follower or different applications like that. But in this audio applications, definitely you want to have the amplification on the output, right? Oh, for some reason now now they're working. Yeah, it's not. Yeah, it's not correctly connected now, so there might be some shorts and stuff. This is heating up, yeah, but that's why it has the heatsink on it. So never mind. Anyways, this was the entire repair. This was basically me misdiagnosing it. However, I figured the only useful thing to know about this design is that you have a single capacitor on the ground for all these amplifiers. So definitely check that one first. And definitely check your input before you start analyzing the output of the op-amp based on the input. And I obviously only have 2 input scope, so I anyways, before you start analyzing that input versus output, make sure that you actually are getting the right supply voltage, the actual right conditions for the op-amp to operate properly. All right, I hope this wasn't too boring. This was a great learning experience to me, that's for sure, and I'm very happy this is actually working. So thank you very much for watching, and I shall see you guys in the next one.